Morning. In this lecture, we are going to discuss about RLC series. So, RLC series means for the previous lecture, we are discussed about RL, RC individually. So, in this lecture, we are discussing RLC. So, RLC means resistance, inductor, capacitors are connected in a series. So, the voltage is applied across three elements. Now what will happen? We have to discuss the circuit and vector diagram and power calculations also along with the applications. So I think see the diagram for RLC series. So the diagram consists of three elements RLC. So connected across supply voltage. The supply voltage is V is equal to Vm sin omega t. The current flow through the resistor, inductor, capacitor is I. That is I is flow through the resistor, capacitor, inductor is same. So that's why it's called as a series resistor. So voltage across the resistor is VR and L voltage across the inductor is VL and CE voltage across the capacitor is VC. So adding of these three voltages are called as the supply voltage. That is already we are mentioning V is equal to Vm sin omega t. So that is VL is voltage across the voltage inductance L and it is leads the current by 90 degree. For VC it lags the current by 90 degree. Always inductor is leads the voltage leads the current by the voltage across the inductor and it leads the current by 90 and for the capacitor capacitor voltage across the voltage across the capacitors leads the current by 90 for VL lags the current by 90 is VC. So this is the phasor diagram. So we have to consider three element. One is R, L and C. So for three element we have to draw the phasor diagram. First we have to consider this is the steps we have to follow to draw the phasor diagram. First we have to consider the reference line, reference vector. Maybe it is voltage or current. Already I mentioned that I is here I is the reference vector. So first we have to consider the resistance. So voltage is in phase with the current. So VR is equal to IR. The same VL is leading and VC is lagging. So we have to consider the VL is draw upward and VL minus VC. So adding of these values, so OAB will giving the VL minus VC, that is IXL minus IXC. This is the steps already I mentioned in the diagram. And VR is equal to IR, VC is equal to IXC, and IXC is equal to 2 pi FC, and XL is equal to 1 by 2 pi XL is equal to 2 pi FL. So adding of these values, that is V is equal to VR squared plus VL minus VC the whole squared. Instead of we have to substitute the values of IR squared, IXL minus IXC the whole squared. So from this we have to calculate I is equal to V by Z. We know that Z is equal to opposition offered to the flow of alternating current, and that is for this RLC. RLC Z is equal to root of R squared plus XL minus XC the whole squared. And this is the phase angle, that is pi is equal to tan inverse of XL minus XC by R. And the power already we are discussed in RC and RL also the same. We have to calculate P is equal to VI cos phi and P is equal to I squared R. And power in RC series circuit, that is whenever we are using the circuit, XL is less than XC, that is act as a series RC series circuit. X is equal to XL is phase angle is 0, then it is considered as the pure resistor, and XC greater than XL is the RL series circuit. This is the power formula curve, that is the power curve for R and L and C, and define and empathy, and application for RLC is tuning circuit, filters, oscillators, power factor correction, wireless communication, audio systems. So for all these are real-time applications of RLC, and this is the my summarization, and that is we are discuss about RLC along with this impedance is Z is equal to R squared plus root of XL minus XC squared, and in for inductance voltages it is lagging 90 degree, and for X is equal to XL, I and V are in phase. Our capacitor is lagging, the voltage is lagging by 90 degree. So F naught is that is resonant frequency. F naught is equal to 1 by 2 pi root LC. So all the informations we are discussed in the lecture. So these are the links we have provided for you all for your reference. And thank you all. See you in the next session in brief about the resonance. Thank you all.